Welcome to Brain Vision.
So we're going to be evaluating this integral here. And the first thing we want to do is acknowledge what the f of xy, g of xy is. And it's clear to us that that's going to be a z squared. So right here we'll put z squared. And then we know that on the inside, we're given that since x equals y squared plus z squared, the way we can write this will be partial derivative with respect to y and the partial derivative with respect to z. So this will ultimately become, once we square all this, we'll get a 4y squared plus 4z squared. And ultimately the reason why that's the case is because if we go back to this right here, what we did instead was we made this in terms of y and z, which means we change these partial derivatives to be y and z. So as such, we'll have z squared, like we said, and then this will be 4y squared plus 4z squared, and this will be dy dz. Then we know that the region inside the circle is inside the circle y squared plus z squared is less than or equal to 1, which makes it easier to use polar coordinates. We're just going to essentially treat y as if it's x and z as if it's y. So because of that, what we'll have is z squared will now be r squared sine squared theta. And then 4y squared plus 4z squared plus 1 will just be 1 plus 4r squared. And then outside of this, we'll have r dr d theta. Now that we have this, this will become r cubed. And our bounds of integration will be from 0 to 2 pi and 0 to 1. Then we can separate this. We'll take the sine squared of theta here and make this d theta. And then we'll get rid of it in here. Once we do that, we see that this integral right here will end up giving us pi. And as we see, this is the same answer as before, 1.489. So this is the same here, pi. And then once we evaluate this integral, what we'll end up getting as a result is our final answer, which will be pi over 120 times 25 root 5 plus 1. And once again, we see we get the same result, which confirms that we did the integral correctly.